Hello and welcome. I thought I would record a quick lecture today. I'm in my office hour lecture time for the morning lab, so I may be interrupted, but here is the current slides for today's topic at hand, which is introducing some physical chemistry journals and an assignment that we'll do relative to these journals. So we call this the current physical chemistry topics and scientific reading assignment. So here, the dates need to be updated, but we'll be doing these presentations throughout the next, well, they'll start in a couple of weeks, so they're not going to start for a little while, but we'll begin these in about 2 or 3 weeks, and then we'll run these for about 3 or 4 of our lecture periods. The morning class is smaller, so maybe just 2 or 3 lecture periods. We might need 3 or 4 for the afternoon period. So the idea is you're going to choose an article you're choosing from one of the journals that we'll show below. You may need to access your OSU account, visit the OSU library page to get journal access if you're off campus. If you're on campus, it's a little bit easier. You can probably just Google the journal title and very easily find it. But if you're from home, go to the library. What you want to do is look for any article of your interest from the current year, or there's this thing called ASAP, as soon as possible. These are articles that have been accepted for publication but have not yet appeared in a print edition. So some of the Chem journals that are relatively popular and worth checking out would be the Journal of Physical Chemistry A, B, and C, Journal of Physical Chemistry Letters, Journal of Chemical Physics, and Physical Chemistry, Chemical Physics. So the Journal of Physical Chemistry A deals with isolated molecules, clusters, radicals, and ions, environmental chemistry, geochemistry, astrochemistry, new tools and methods. I think you'll find most of the articles in A maybe a little bit more approachable than some of those in B and C. JPC B and C get into biophysics, biomaterials, liquids, and soft matter, which may be topics of interest to you, but also I think tend to be somewhat deeper in some of their the physical chemistry topics. The other Journal of Physical Chemistry is C, so that's energy conversion and storage, catalysis, sort of materials, magnetic properties, nanomaterials, etc. Journal of Physical Chemistry Letters are shorter journal articles. It's kind of the journal I think most people should probably gravitate to first to get a sense of some relatively short articles that might be a little bit more approachable. And this sort of includes all topics of physical chemistry. And then you have Journal of Chemical Physics. If you're a little bit more on the physics side of interest in terms of chemistry, this might be a journal for you to check out. You might see articles on theoretical methods, advanced experimental techniques. I, in particular, think the discussions on atoms, molecules, and clusters, you'll find the Journal of Chemical Physics is actually divided into sections. The atoms, molecules, and clusters, I think, would be the main section for looking for like a Chem type topic that might relate to something relatively straightforward you could discuss during our presentation. Liquids, gases, crystals, surfaces, interfaces. So some of these topics get into some more advanced and interdisciplinary topics of physical chemistry and chemical physics. So then finally, physical chemistry, chemical physics includes all topics of physical chemistry and chemical physics. I think it's kind of an interesting journal and you'll find all kinds of interesting papers there. So the way this will work is you'll carefully choose and read your article. You'll prepare 3 to 5 minutes of presentations through PowerPoint slides. Screenshotting the articles is sort of our recommendation. I'll give you a sample presentation here in a moment. Actually give you 2 quick sample presentations. To kind of show you how you can relatively easily put these together. Deliver your presentations, maybe field a question or 2. So we're talking, 3 to 7 minutes per presenter. We'll post a schedule later in once we get closer to when these start up. So address the purpose, claims, data, discussion, conclusions, consequences of the study. In essence, read the abstract and then look at the paper to try to understand the abstract, because essentially this is all the information provided in the abstract. So maybe think about how the abstract's written and then read the paper to understand what it's getting into so you can discuss these topics in your presentation with a little bit more brevity than just the simple words that are in the abstract. So generally try to attend via Zoom all the presentations during lecture. We'll give you points for attending. We'll work this out as we get closer because there may be some challenges with attending, but we'll work out something that's fair. Hopefully we can get more than just the presenters for a given day attending the presentations. And then we'll give you 25 points for actually giving your presentation. So here's a few sample presentations. This is actually from a student that had prepared this presentation. And so this paper was titled The Photodissociation Dynamics of the Simplest Alkyl Proxy Radicals of Methyl Proxy and Ethyl Proxy. and this is done at 248 nanometers. And so you might wonder why they would choose 248 nanometers. It's a relatively easy laser wavelength to come up with what's called an excimer laser. But anyway, so they were generating. They had to come up with a technique for generating these radicals in the gas phase and molecular beam methods. And so the paper talks about how they prepare beams of the anions complementary to these radicals that they then photodetach an electron from the anion to generate the radical. And then they investigate the photodissociation channels and then precede that radical formation by intersecting the beams with that 248 nanometer radiation. And so then they provide some theoretical framework from some calculations that have been done. I believe this was work that had been done previously, not being reported in the paper, but this is some pre-published work that they cite that had looked at some of the different pathways that are possible for the fragmentation of the actual radicals in the middle. And there's a fragmentation pathway to the right, a couple of different fragmentation processes to the left. And the same thing for ethyl peroxides. They're just looking, kind of comparing the relative barrier heights. You might expect that the most taken pathway would be the lowest energy pathways. Of course, there's some inherent uncertainties of each of these transition states from the methods that were used. So these aren't exactly known, but this is just something that had been previously known. And so they're just sharing some of those different pathways. So they were looking at some of the different channels. In the previous slide, you could look at, you might appreciate that there were some different channels that the radicals could undergo reaction. And what they did was they compared their observed channels for those sort of dissociation pathways from their experiments. So they're just looking at the percentage of total events that went by each of those particular pathways that they were studying, or comparing with the theoretical framework for those mechanisms. And so they're finding like the direct O loss is a majority of the pathway for methyl peroxy. Not the most taken pathway for ethyl peroxy. About 30% of the channel they found went through that pathway. Most of the channel went through forming a methyl plus O plus formaldehyde. That was the most taken pathway. But you can see there's a few different pathways for ethyl peroxy. Now, what excited me when a student presented this paper was that I had tried to generate methyl peroxy when I was in grad school. So here's a section for my PhD dissertation. And I always find this word interesting whenever you're reading somebody's dissertation. Whenever you see like the attempted, if you're in organic synthesis, it's always like the attempted synthesis of, whatever the molecule is. In this case, it was the attempted photodissociation of methyl peroxy in the UV region. And so we tried to generate by photodissociation. We attempted to observe the photodissociation methyl peroxy beam at around 240 nanometers, but we were unsuccessful in generating the actual beam of methyl peroxy in the first place. So I thought it was interesting that I tried to do this experiment when I was in grad school, probably about 15 years ago from now, and about, I don't know when the student presented that paper, 3 or 4 years ago, that paper was presented, and I was like, wow, interesting. So I was fascinated by that a student would choose, a paper so near and dear to my previous work. But anyways, one of the papers I'd come up with a few years ago, a quick discussion to introduce the topics, is the methanol-assisted phthalimide ring opening as a concerted or stepwise. And so you might, think when you give your paper, just take a screenshot of that abstract, maybe include the opening picture, because what they're doing is this is the main molecule they're looking at. When it reacts with methanol, does it undergo a two-step process for ring opening, or does it undergo a concerted ring opening process? So a very straightforward article, and that it's looking at a theoretical study. So it's doing computational modeling using computational chemistry, and it's looking at the first, concerted pathway, and then from there, they're evaluating the barrier heights. They're also looking at solvation. So they're actually adding a methanol to the calculation to sort of mimic the solvation process of this type of compound. So they're increasing the number of methanols. So the N here is increasing with 1 versus 2 versus 3 methanols in the calculation. You can see that methanol is serving to lower the barrier height through some sort of solvation process. And so then here we start on the left with the molecule. Again, we go through a two-step process, or a first barrier and then our second barrier. And again, they're looking at the numbers of methanols that are added to the calculation. Again, seeing more methanols or decreasing the barrier heights through, again, some sort of solvation process. And so then, finally what they're trying to do is compare, okay, which of these barriers is overall higher compared to the first pathway. And they find that the stepwise pathway is actually lower in energy. in terms of its barrier heights. They employed this DFT method, seemingly successfully. They mentioned that some other pathways may be competitive for other reactions involving some hydrogen atom transfers. I can't quite recall what that statement's about at this point. But what you might do with your presentations is kind of think of, including, 2 or 3 or, as many of their data slides as you can that show graphically or in table form what their results were. And then a quick little conclusion slide where you try to come up with a few bullet points and maybe do a slightly better job than I did of trying to remember how they tie back into the actual article. So just come up with a few talking points to wrap up with. So I think most presentations just start with a title slide. A lot of papers have this, like what's called TOC graphic or table of contents graphic. So include that in the paper because it provides an easy way to try to explain the topic of the paper. I wouldn't read the abstract, but you kind of have the abstract there that you might be mentioning a few details out of this as you go along. Interestingly enough, we've probably all seen enough computational chemistry to even notice that the MO6-2X, this is like a DFT method, that we probably recognize the basis set. I think we actually use a basis set like that in one of our experiments. And so then just a couple of slides with data and then a conclusion slide. So, 3 minutes or so per person, question or two is what we're looking for. So that's our physical chemistry literature discussion and the assignment for the presentation that'll go along with it that'll start up in a couple of weeks.